Today we're going to do a very quick but basic lateral stability analysis on a simple building of a regular grid with one or more cores of any shape, and we're going to be able to control any of this parametrically and see the results such as this. If I turn off the model, you can see how the building's deflecting and some of the stresses on the core from that wind hitting the side of the building. And it's easy to just move the core around, or even have two cores. Add them to the script and run the analysis again. And we can see that stiffened the building up a lot. And a reminder, you can get more tutorials like this at our website. And you can also download some of the scripts in this area here. And we've got some demo scripts you can test out as well. And feel free to have a look at some of our other services. We've got model conversion, rapid framing from architectural models, engineering visualization, reinforcement, and a lot more. Okay, so to start off, we're going to build a structure as quickly as possible. But obviously you can do this any way you like. So we're starting off with this square grid component. And I'm going to put in a panel and say that I want a grid of 8 by 8. Now the next thing is I want to also use the perimeter for something. So if I use this component, which is the regional union, that's going to take all these little squares. If I flatten it, I've got to flatten here, takes all those squares and adds them all together as one curve, and then gives me the perimeter. Then I'm just going to do some steps to clean it up a little bit, and that's simplify curve, because it will still have, that box will still be made up of individual curves. So if I simplify, that makes it have 4 edges instead of 4 edges made out of 5 lines. And it is as a polyline curve. And then I'm going to explode that. So you can see that I've got my 4 lines that I want. Then from that, I'm going to extract one of those elements, element 0. You can see that highlighted there in the Rhino window. And I'm going to use that as my base for my wind load hitting the building. Now if you go back a step, or use our grid further, I'm going to set up a series, and this is going to be our floors. So I've got our grid, and I'm going to make a series of floors. Now it's going to start at 0, the step is going to be 4 meters. That's why I've got 4 there. And the count is 10 at the moment. I'm just going to leave it as a 10-story high building, but obviously easy to change. And then I want that as Z, so a vertical change. So I'm going to use that series to make a vector out of each of the levels. Now the other thing I'm going to need for this simple model of the building, and to allow it to resist wind load, is a core. So I've just used the curve component, and I'm just gonna create a polyline in Rhino to keep this quick. And it's just going to be a rectangular core. I'll just select that and set one curve. So you can see it's recognized that. That's going to be the core of our building. Now, to make that solid walls, I'm going to use extrude, and I'm going to use extrude along a vector. So they're my walls, and the vector I want to extrude it is 4 meters. So I'm going to just use this 4. I'm not going to use a series because I'll use that later, but just initially I'll extrude up one level. So that's one level of core. Now to get the rest of the levels for this core, I'm going to use the move command. And I'm going to use the vectors that I've created in my series here and copy them up. Now if I turn that one off because it's a double, I've actually got one too many cores, which you'll see once I copy the floors up. So to get rid of the top core, the easiest way is to just use a shift list, use my vector list, and set this to false, which means it's going to shift that list of vectors by 1. And if it doesn't wrap, it'll drop one off the end. Now it's going to start off by dropping the bottom one off, which I'll show you. So I actually want the top one off. So if you change the shift to -1, there we go, we've got the right number of cores now. Now the other thing we can do is go back to our structure, our grid structure and our perimeter, and we're going to use another one of these regions, and it's going to be difference, region difference. The region's going to be the perimeter of the building minus the core, and the core is this curve here. So that gives up 2 polylines, but it's actually the region inside these 2 polylines, so the inside of the core isn't included. And when I use this next step, which is the boundary surface, which makes a surface from boundary curves, you'll see that effect. So you can see that the core is empty and the rest of the floor plate is a region, is a surface. Now obviously now or later I can just move this core and the script's going to automatically update itself, which is exactly what we want from Parametrics. Now I want to copy this floor plate that I've created up. So again, I'm going to use move. Defaults to 10 in the Z. But I'm going to use another shifted list. So if I go to sets, shift list, and this time if I just change this to false, it'll drop the bottom level. So remember, we're not using this one here. We're just going to use the output of this component, so we don't want the base floor, we just want all the other floors. That's why I dropped that top level off of the core. Okay, so we've got a basic structure. Now we need to put some columns in. And to do that, we can use an output of the square grid that we've already made. So if I just shift this down a little bit, gives us some space. I'm going to use move. I'm going to use another Z. And it's going to be the 4 meters again. So I'm going to take these points, I'm going to move them up, project them up onto the next floor. I'll flatten that. Then I'm going to create a line, or lines, series of lines between 2 points. The first point's going to be the lower points, and the second points are going to be the points I've just created. I'm going to flatten that input there. And I can turn off this. We can see we've got our first level of columns throughout the building. And then once again, we can use the move command, get that geometry. We can use the same shift list that we've already used before to copy those up, but we have to graft it because we've got a list of 36 lines, and we've got a list of 9 lines, but we want all 36 of those columns to be copied 9 times, so we've got to graft this input. So there's all our columns, and there is 324 of them. Okay, that was just building a very quick, easy structure. Now I'm going to put it into Kiwi 3D. You could obviously use Karamba for this, or another component that does structural analysis. The basis of it is an analysis model and then a solver. So to build the model, you just need a few of these components. I need a type of analysis. I'm just going to use linear for the moment. You need some elements. Just move that over a little bit. So I'm going to turn what we've created here into structural elements. And the floors, I'm going to use shells, shell elements. And you just simply put that in to create a shell element. It still needs M and R. M is a material, so I'm going to make it concrete, and R is a refinement. So if I do the material first, not that one, I'm going to use this here, which is material defaults, because this T value, if I go to parameters and I select value list, it will give me an easy list of some common materials, so I don't have to fill in all the properties. I'm going to use concrete. put that into material M. The refinement is going to be a shell, so if I go back to Kiwi and I need a surface refinement, there's curves, which are basically lines or surfaces. So the shell is going to be a surface refinement. Now we need some supports. For this I'm going to use support points. And we can use what we've already created, the support points from the original grid. I'm just going to flatten them. Now these default to fixed in X, Y, and Z, and they're free to rotate and free to twist in torsion as well. So let's start plugging some of this in. They go into E, S goes into supports, and you can see it's already started to create a model. In fact, I'm going to go back and turn off some of the Grasshopper components just to clean it up a little bit. I'll just leave some of these for the moment. The next thing you're going to need in the model is a load. And if you remember from the start, I isolated one of these curves for a load. So if I go to line load, curve load, we've got our curve, but we need to copy it up again. So to do that, the old move command, and I'm going to use my shifted list. So those green lines are going to be where the load comes in on the building. This is a lateral load simulating a wind. And I'm not going to change much of this except the direction. Defaults to Z, so it's a gravity load. But I'm just going to make a panel here. Oh, sorry, I'm just going to make a Y vector so that it loads in the Y direction. So direction is Y now. And this value here I'm going to leave as 10. So I can put that into loading. You can see a description, a depiction of that in the Rhino view. And the last thing to do for the basic outline of the building is the beams, which are, or the columns I should say, which I'm going to use the beam element, which achieves the same thing. We've already got our columns as lines here. So I'll put those into the C, which is where the curves go in. Material is concrete again, we've already got that. I'm just going to flatten these curves too. Now what else does it need? It needs S and R. S is a section size and R is a refinement. Section size, I'm going to just do it very quickly. Use a box section. 0.2 by 0.1. I'm just going to make it 0.2 by 0.2. So 200 mil by 200 mil. Pretty skinny columns, but we're not doing analysis that needs a lot of correct numbers in it. It's just a demonstration. And the refinement this time is going to be a curve refinement because these are curve elements. So there are beams, that goes into elements as well. just hold down Shift to add an additional input into elements, and you can see it's built that. So you can see what it thinks the model is in the Rhino view. Now I can turn off some of this other stuff that was left over from when we built it in Grasshopper. And now we do have a basic building all ready to go, but we're going to put this core. The core isn't in there at the moment, although we've already built it, so it's really easy to do. And to do that, we're going to treat these walls of the core that we've built as shell elements. We've already got the surfaces, so put that into B, which is reps, or B reps. Then material, M, again, is concrete. Refinement, again, is surface. Done. Put that into element, hold down Shift again. You can see where it's put all the linkages to the rest of the structure. So that's all linked together. And then last thing is we need support for our core. So for that I'm going to use the support curve, because we have a curve already at the bottom of our core. So that's really easy. And again, they default to fixed in X, Y, and Z, which is fine. And we put that into S, so hold down Shift and S. And you can see there, all along the edges of the core are supported. Now we can plug that into the solver. Okay, so we plug that in. We need to just set up a button to activate the solver, because it defaults to false. If I click this, it will run the analysis. You can see that in this window. Done. We're going to use this deformed model component. Plug the model into that. Now to see the results a bit clearer, I'm going to scale it up by 100. And I'm just going to turn this off, the preview of that off, and you can see how the structure's reacting to that load that's coming in from the Y direction at every floor, which is simulating a wind load. You can see the whole building is moving over, getting translated over at each floor. And there's also a bit of twist as well, which you can see in the core. It's actually twisting because it's off center. And we also want to see some color plots. So instead of just using the old model, the static one, we can use the deform model. And we need a type, so this is another value list from the input components. So that's displacement. I'm going to use N1, which is effectively stress. I'm going to turn off the deflected model there so that we can see the results. Now I'm going to also have to turn off this core here so it's a bit clearer. And now you can see, and to see what the values are in display, you've got legend, and this C and T are inputs for that. So you can see we're going from minus to plus 1800 or 1900 almost. And the negative is compression, whereas positive is tension. So as this wind load hits the structure, it's trying to compress this side of the core, and it's creating tension. It's trying to crack the concrete on this side of the core, which is what you'd expect. The other thing is, as I said before, with the twist, you've got higher stresses along these edges than you do the other side, because basically you've got more load over here than you do here. Now I'm quickly just going to put also the columns into this deformed view, and that's with the 1D elements. Same thing. So we can see our columns along with our shells. Now the cool thing about this is obviously you can just drag that and move it around. And then you just run the analysis again. It's working away. And you can see how the building's working with the wind in that core location. And obviously you can just quickly change these lines, just stretch it or anything like that. You can also copy. So say I've got two cores. I want a core over there and there. I just set multiple curves, run the analysis again. And this should have a big effect if you've got two cores. Now the reason that happened was that I didn't graft this move back here. So when I created it's created two cores at the base level, which is correct. If I unpreview this, it's copied that one and that one because of the way the lists work. I've got two reps now and a list of 9 translations. So it's going to do the first one with the first translation, the second one with the second translation, and then use the rest of them for the second. So to get around that, you just graft that, and that creates what we really want. So I'll turn that off again and then run the analysis. There you go. And if you remember, it's a lot less horizontal deflection in this model with 2 cores than it was with 1. And we've got a lot less stress as well. We had 1800 or 1900 before, now we've only got 705. So that's just a very, very quick way to get a feel for a building. And obviously everything's parametric, so you can change the layout of the columns, the layout of the cores very quickly, run the analysis and see the results. and you could create a parametric building in any shape you want. You could twist it, scale it, anything like that. But it just shows you how useful some of these parametric tools are as compared to traditional software. And the other thing to note is you can quickly export these models into Revit or export them into ETABS or Spacegass or another analysis program quite easily. We can do that. There's other methods of doing that as well. So it's a real good tool to use these days that a lot of engineers aren't maybe not using yet, but it's very quick and easy. It can be. Thanks for watching this structured parametrics video. Leave a like or subscribe if you found this useful, and we'll see you in the next one.